Okay, this is lesson 5.4 on conditional probability and independence. We'll see some of the same examples, but asking different questions. Probability event that can change has occurred. So, for instance, if you toss a fair coin twice, the sample space is all the possibilities, right? So you've got heads, tails, so forth. What's probably getting two heads is 1/4 because there's four possibilities, and one of those is so all those are equally likely outcomes, so it's 1 out of 4. Suppose the first toss lands tails. Now the probability of getting two heads is 0. So that's a conditional statement. So if something has already occurred, then what's the probability of that other thing occurring, kind of a thing. So knowing the first toss definitely changes the probabilities. Okay, so remember the taco tongue, the evil eyebrow. Let's turn our attention to some other interesting questions. Okay, so if we know that a randomly selected student can evil eyebrow, so if we know that's true, so that's the given. Sometimes they don't use the word given, but that's the given statement. So we're only looking at evil eyebrow yeses here. There's a total of 62 people we're looking at. Of those 62 people, what's the probability the student can taco tongue? So 42 out of 62. So we're looking only at those yes for evil eyebrow. Of those, we want the yeses for taco tongue. So 42 out of 62 would be our proportion, or 0.677 if we type that into our calculator. So if we know the condition is, or the given statement is, if we know that a student can taco tongue, so we're only looking at taco tongue folks. How many folks are there? There's 149 taco tongue folks. What's the probability that student can evil eyebrow? So now I want to know, out of all the taco tongues, how many can evil eyebrow? So out of the 149, there are 42. So 42 divided by 149. This is not that difficult. It's not that bad, right? Once you get the hang of it, but it could be the row or the column that's conditional here. You have to kind of look, read the question in the context. Is it a conditional statement? So this is the definition of conditional probability. The probability that one event happens given that another event is known to have happened, has already occurred, is called conditional probability. And the notation, here's what's interesting. So the conditional that, so this probably a B given that A has occurred. So this line there that you see right between the B and A, that means given. What's the probability that B happens given that A has already occurred or has already happened here on that condition? So that's the notation that we'll use for this. So the same question, probability that taco tongue, given that you have an evil eyebrow, is 42 out of 62. Probably the evil eyebrow, given that you have taco tongue, is, that. Okay. Who rides snowmobiles in Yellowstone? That would be fun. Yellowstone National Park surveyed a random sample of 1,526 visitors to the park. They asked each person whether he or she owned, rented, or had never used a snowmobile. Respondents were also asked whether or not they belonged to a club organization. The two-way table summarizes the responses. Suppose we randomly select one of the survey's respondents to find events E as the environmental club member, and S as the snowmobile owner, and N as never having owned a snowmobile. So what's the probability, I'm going to read this statement in context, that you've never owned a snowmobile, given that you are a member of the environmental club? So environmental club members, there are 305 of those, right? So of those 305, how many of those have never owned or never used a snowmobile? That would be 212 out of 305. So out of those, right, 212 divided by 305, we got it. If you want to say it in context with a sentence, given that the randomly chosen person is an environmental club member, there's about a 69.5% chance he or she has never used a snowmobile. Second question, given that the chosen person is not a snowmobile owner, so that's the condition, that's the given statement, what's the probability that he or she is an environmental club member? So given that you're not a snowmobile owner, Okay, so that's kind of a tougher one. So not a snowmobile owner is actually like there's two categories that fit the bill there. So you could have never used a snowmobile, or maybe you're just a renter. I'm in the renter situation. So you add up those two numbers. So the given is the 656 that have never used one and the 574 who have only rented one. So those are the people who are not snowmobile owners. So those two together are a denominator, or a given statement here. What's the probability that he is an environmental member? So then we add up the 212 plus 77 for our numerator. Um, and you just add them up, right? And you get the probability, 23.5%. Probably the taco tongue. Okay, so this is an interesting idea. Um, of saying it differently. So I really like just the way we were doing it. It's pretty easy, actually. It's not too bad. But another way of looking at it is we look at it as probabilities. So let's just look at the denominator as probability of evil eyebrow. That's our conditional statement. So whatever's the conditional or the given statement goes in the denominator. So what's the probability of being evil eyebrows? So evil eyebrows are 62 total out of 200. That's the probability. Taco tongue and evil eyebrow. So there's only 42 of those folks out of 200. If we divide those fractions, remember you multiply by the reciprocal, the 200 kind of goes away when you simplify that fraction, and it ends up being 42 out of 62. It's kind of a long way of getting there the same way we were getting there. I kind of like the first way, but you could just use straight up probabilities if you put the conditional statement in the denominator. So that's where this formula comes from. I don't think you need this formula. You can write it down in your notes. I think it's great to have, but in most cases, you're not going to need this. I'm more interested in that you just understand that the notation here. So that first statement is read the probability of A given that B has occurred, which means the probability of A and B is in the numerator, probability of B, the given statement, is in the denominator. And again, we can use that notation that A intersect B is the same thing as A and B there. So just a notation is more what I'm concerned about there, that you understand that. Okay. We classify students, remember the New York Times, the USA. We had that nice Venn diagram. What's the probability of the random selected student who reads USA Today? So how many folks read USA Today? So if you look inside that circle, there's 35 plus 5. So there's 40% that read USA Today. So out of that 40%, that's my denominator, 0.4. How many folks read the New York Times? So that would be the 0.05 divided by that point, 0.4, basically, which is 0.125. Okay, suppose you toss a fair coin twice. Define event A. First toss is a head, second toss is a head. We know that the probabilities individually are 1/2. So what's the probability that B occurs given that A has already occurred? So the denominator would be, so probability of A, right, is 1/2. Um, so this might be a case of using the formula, right? Because the second probability of both of those events occurring. So, oh, this is an interesting way of looking at it. So you don't have to do a fraction like we've been doing for this one because the first event has already happened, right? Given that A has already happened, there's really only one more toss, right? So you could just think of this as, well, there's a 1/2 chance of getting the second toss um, to be a heads, right? So there's different ways of looking at that. Um, but it's basically one has already occurred. So you don't need to even, it's almost it's a hard problem because it's almost so simple that it's more difficult in some ways. Because you don't have to use the formula there. You could, but you don't have to. Did not change the probability of the second toss as a head. We say that those events are independent. So that's different than mutually exclusive. Independent events, there's probably a formula here. Here they are. if knowing whether or not one event has happened does not affect the other event. So the two events don't have any effect on each other, right? So given that B has already occurred, doesn't affect A at all, or vice versa. So they have no effect on each other. So let's contrast this. So are the events taco tongue and evil eyebrow independent? So it's a good question, actually. So if you have one skill, are you more likely to have the other skill? Well, that might be the case. I'm not sure. So let's suppose that a student, so we answer this question first. What's the probability of having evil eyebrow given that you have the ability to taco tongue? So out of the taco tonguers, there's 149. Evil eyebrow is 42 out of those. So 42 out of 149 would be that proportion. So if these are truly independent, then the probability B should be the same. Probability B being the probably just evil eyebrow with no condition should be the same because taco tongue is not having any effect, right? So what's the straight up probability of just probability B? Probability of evil eyebrow. So there are a total of 62 out of 200. If we do that percentage, I mean, we could do it that way too, but 62 out of 200 is not the same as 28%. Those don't match. Also, the probability of no taco tongue, you could look at different ways. But I was looking back at this formula here. So probably the A has occurred given that B has. A probability of A given that B has occurred is the same as the probability of A. If you test that, which is easier to test than what they did, you're going to see that, oh, is that what they're doing now? Yeah, so 0.282, and that's 0.31. So those are not the same, right? So because they're not the same, those events are not independent. Evidently, the ability to taco tongue decreases the ability to evil eyebrow, potentially. So these are not independent events. So we can look at the table and check those relationships there. There's a relationship between subject taught and handedness. To find out, we chose a simple random sample of 100 teachers at a conference. And here's the relationships. Our events teaches math and left-handed independent. So let's just kind of figure this out. So let's pretend that you are left-handed. Given that you're left-handed, what's the probability that you teach math? So given you're left-handed, there are a total of 10 left-handers. And teaching math out of those 10 would be 7 out of 10. So 70% of left-handers teach math. So then what's the probability of just teaching math overall? So that would be 46 out of 100, which is not the same. So those are not independent. Let's see if they did it the same way we did. I did. So probably that, they did it in reverse. So probably left-handed, given that you teach math, is 0.152. And then the probability that you're left-handed that you don't teach math, 0.056, those don't match. Or again, we could have just done probably being left-handed is 10 out of 100, which is not the same. So those don't match. I prefer that way, actually, when I do this. So they don't match, so they're not independent events. So yes, so if they're not independent, then knowing a teacher's subject might help us predict which hand is more dominant. So because the scales, if you did a bar graph of that, they're not going to match. They're not independent. So then this is what you would try on your own here. Students in New Hampshire received 10,000 course grades at a recent semester. The two-way table breaks down those grades. Okay, so we have all the data. Choose it. University of New Hampshire course grade at random. E is the grade that comes from an EPS course. L is the grade that is lower than a B. Ooh. Okay, so what's the probability that you grade comes from an EPS score? So find the probability that you have a grade lower than B, given that you are taking an EPS course. That's what you would say in words. Are L and E independent? Well, let's test it. So let's find that probability for number one there. So given that you take an EPS course, so which is engineering and physical science, so there are a total of, do I have to add those up? It does look like I have to add up all those numbers. So 368 plus 432 plus 800. Those are all the engineering and physical science students. So you add that up, that's my denominator. Given that you're an EPS student, what's the probability that you're lower than B? That would be 800 out of that total. To check, well, let's just find the probability overall of being an EPS student. I'm sorry, of having a grade lower than B. So that would be add up all 9 of those numbers. That's my denominator. Add up only the lower than B, 2268 plus 800 plus 588, and that would be my numerator. And if those two numbers match, then you have independence. If they don't match, you don't have independence. That's your lesson for today.